This is something called the gambler's fallacy. And I find it so interesting because people get it wrong so consistently. The general fallacy. So let's just start here first, right? To explain, you have a coin here, and we're going to assume this is just a normal coin. We're not going to get weird with it. It's just 50-50, boom, done. That portion's simple enough. And then the next portion's also pretty simple. What's the odds of getting heads twice in a row? You have to get heads and then heads again. It's another 50-50. So therefore, you've got this sort of four-way here of 1 in 4 chance. Going down one more layer, you get 1 in 8 chance. Becomes 1 in 16 eventually, because there's 16 different things. This is as far as I went, but this would continue forever, even for 50 heads, right? And that portion is not unreasonable. Getting 10 heads in a row, anyone would say, oh yeah, for sure, that's a very low chance. The part people get wrong is they assume that if you got 9 heads in a row, the odds of getting a tails is massive then. 100% all in on that. If you were betting all in on tails because you've already got 9 heads, there's no chance you're going to get another heads. That's wrong. The previous rolls, I should say flips in this case, don't matter towards the current flip. They're all independent from each other. The odds of betting on 4 heads in a row is ridiculous at this point. Look at all these things. That's insane. But if somebody already flips the coin and gets a heads, look what happens. By nature of this diagram, all of these different permutations require to get tails first, which means every single one of them just disappears immediately. They're just gone. We're only left with this tree because we got a heads. We know we have a heads already. The same thing will happen again. If we get a second heads, we already know you have 2 heads. That's no longer up for debate anymore. So this tree disappears too. They're no longer possible. Once again, you get the third heads. At the end of all of those heads, we're still left with a 50-50 chance.